What is stochastic gradient descent of momentum? See the graphic below. We have the local minimum and the global minimum. In the optimization problem, you might get stuck in the wrong place like the local minimum instead of global minimum. One way to increase the probability to get the global minimum is to do the gradient of momentum or velocity. See in the equation that the velocity is a function of past velocity and the previous gradient. Alpha is the weight that you give to past velocity and varies from 0 to 1. Epsilon is the learned rate that we saw in the previous video. In other words, velocity is the exponentially decay average of the gradient. Imagine that the gradient is a ball and the velocity gives momentum to this gradient to pass the local minimum and get the global minimum. Other advantage of the gradient of momentum is, for example, the red path gradient. It converts faster than the black path gradient without momentum. Basically, see that the black path gradient wastes time moving back and forth until get the optimum. Now let's introduce the concept of Nesterov momentum. But first, let's formalize the gradient of the regular momentum. We take the gradient of the loss function in respect of the parameter theta. Now let's see the Nesterov gradient. The only difference is that the Nesterov gradient is evaluated after the current velocity is applied. Just look to the additional term in the loss function, the alpha times v. Let's summarize. Velocity is a function of past velocity and past gradient. Then theta is a function of past theta plus the velocity. This is an iterative process. We keep doing this until we get the optimum theta and hope that this optimum is the global minimum, or at least a reasonable minimum.